Hey, welcome all to ST System Design session. And today we are going to do a mock interview where Abhishek would be the interviewer and Bin and I would be a candidate. And they would be solving a system design problem for next 45 minutes or 50 minutes. And during that time, generally, they would be talking and the audience would be listening and can comment in the chat section of the Zoom. So after they're done, we can all share our feedback and uh, it's some constructive feedback or good feedback. So it could help both the candidate and the interviewer. Okay, over to you, Abhishek.
Yeah, thank you so much, Jasmine. Uh, Hi, Menini. I'm Abhishek here. How are you?
Hi Abhishek, I'm good. How are you?
I'm good, thank you. Okay, so we are going to discuss a system design problem today, as Asim mentioned, and probably will take like around 50 to 55 minutes. Um, so before we start, do you want to just give an introduction about how much experience you have on the system design and backend development?
Sure. So I have around 7 years of backend development experience. Since last 3 years, I'm working on participating more actively in designing systems and working on microservices architecture.
Okay, great. Okay. Okay. So the system that we want to design today is basically a peer-to-peer file sharing network where like someone can choose to either be a host to share the files, or they can download the files in the network, right?
Okay. Sure. Okay. So is it going to be like something like Google Drive or something, Dropbox kind of thing?
Uh, so Google Dropbox, how is it? Why do you think it's a peer-to-peer system?
Yeah, it's not peer-to-peer actually, right? We keep in one centralized system and then we pull from there.
Yeah, right.
Yeah, yes. So it's more like torrents, right? Something like I can assume it's
Something like
something similar to that.
torrents, you can say, or like in your university or somewhere, like we have this,
Yeah, we have DC++ kind of
right?
thing. Okay, yeah. Okay, okay. So, so what kind of files our system is going to store?
It could be any kind of file. So for my system, it's just some bytes of data, and that could be anything.
Okay. Uh, who are the users of this system and how frequently they use this system?
So how frequently? I mean, uh, I don't know like how frequently they would be. Yeah, I mean, I can say that people use it a lot to share the files among each other. At some
Okay,
point, there could be a lot of usage. At some point, there could be less usage, like at nights or sometime when the people are not.
okay, okay. So users are it could be anybody, right? Or it's in a specific to colleges or something. It's a universal, anybody can share to anybody kind of system, is it?
Okay, let's probably start with a simple thing and then we can maybe see. So let's start with a simple system where we are designing a peer-to-peer file sharing for a university. So like for my university, I'm designing a system file sharing. So now let's say it is limited only to my university. Uh, it's not like outside. It's not available outside. Let's first try to solve.
Okay. Okay. Uh, do we have any limitations on the file size? How much I can share?
They like d- I don't think we need a limitation like that. But if you want, like you can, like if you want to put some limitation, I'm fine.
Okay. Okay. So ideally, no limitations. Okay.
Yeah.
Okay. And are there any other features the system supports? Like, what are the usage patterns if I want to share a file? I mean, how it works?
I'm sorry, can you repeat?
So, what are the usage patterns of this system? Like the person who is uploading the data, or person who is trying to download the file from the system.
Mhm.
So, what should like? Do we have any interface where I can upload documents or like?
Yeah, right. Okay, so basically, let's say we have three, like we need three main functionalities out of it. So
Okay,
one is that I can choose to be a kind of a host and share files, right? Then
okay,
second is I can choose to be kind of a client and download the files. And third thing is that I should be able to search for the files which are like available for me to download. Like I should be able to see a directory of shared files in the entire network so that I can choose a file of my interest and download it if I need to.
okay, okay, okay. So as a client, if I want to download file, I can just as you said, I can. So we need a search functionality, right? So to see what all files are available,
Yeah,
what all
and
users are available.
yeah, and don't focus too much on like the implementing search for the files. Like
Okay,
I'm just saying that it should show all the files. So like let's make it simple that it should show me all the files which are available
okay,
in the system so that I can pick that okay, this new file is available, this new file is available and I can download it, right? I should be able to see what all is available for me to download in the system. So it's
okay,
simple, no search or anything fancy.
okay. And do we need any access permission kind of thing? Like once I upload a file, anybody should be able to access that and download it, or we there will be any constraints the host can share to only particular group of people?
No, like for yeah, a file is shared by everyone in the network. So in my university, the file will be shared by everyone.
Okay, and like let's say I have uploaded my files in my in my machine, and then for various reasons people are downloading those files, and if I suddenly remove those uh, users experience, I mean they'll not be able to download it completely and it will be interrupted, right? So what is the expectation during those scenarios?
Yeah, that that is a possible scenario, and uh, so basically, if my file, that file, if I was the only host, then
Okay.
then yeah, that file becomes unavailable. But if there were multiple hosts for the same file, then then the system should try to redirect to the other host which now has the file. So
Okay.
basically, let's say there is file X, right? And
Right.
I started sharing it and I have that file. Now, when another person in the network, he has also downloaded the file, then he can also be a host, right? So there could be two hosts for the same file. So
Yeah.
now, if someone wants to download a file, he has two hosts available from which he can download the file. So in this case, if let's say we started the connection with one of the host and that host has gone down, then we can switch to other host. But let's say if we had only one host, then yeah, then we don't have any other option. Then the file will be left interrupted and it could not be downloaded further.
Okay. So that means so we need some mechanism. So multiple people can host a same file, and we need a mechanism to identify whether two files are same or not. Right?
Yeah, yeah.
Okay.
And and let's keep it like simple for now. So let's say that we have like let's not worry too much about identifying if the files are same. Let's say like a file with the same name is and same size and same properties is considered as same file, right? And so like even if like you are not going to do something fancy, that if a file, although it has same content, but if it has a different name, then you are trying to interpret it as a same file. So like let's not do those things. I mean, we could do those things, but in the
Yeah.
interest of time, let's keep it simple. And
Okay. 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 And how many users we are expecting to use this system?
so in a university, we can consider that, yeah. So yeah, but let's consider that I have a big university. Like my university has like around, let's say, 20,000 students. And
Okay. Okay. And how much load we can expect? Like how many writes and how many reads? Like
so like so these are the users, 20,000 users, and they would be like, so they will be uploading like around, you can say, around 1 million. Like in my system could have 1 million files or so. And basically, because it's a peer-to-peer system, so these values could vary a lot. And that's the whole point, is that I don't have to worry about like how much is the size, right?
right.
Because like it's not my responsibility. A central server is not hosting it. If the load
Yes.
increases, then it is shared, right? And so
Right.
I don't have to scale up my system or something. So
Okay. Yes. Okay. Sure. Okay. So I think I'm good with the requirement now. So so basically, since it's peer to peer, as you said, there is no centralized system where we keep servers and all. So it will be the so we can design one client which will be available in all the users of the system. So it will be it will have like so I can what I'm thinking is it will have two components. One is the client, another one is server. So this will be sorry this will be running in each of the users machine.
Mm-hmm.
Client will be used to download the files, and server will be used to uh, serve the user requests to get
Okay.
the data. Yeah.
So, okay, so my like application will have these two components, client and server, and
Yes.
like every user will have to download these two components, right?
Yes.
Okay. Mm-hmm.
So it could be single application from
Yeah.
the end user perspective. It will have two different components and with the different responsibilities.
Right. Right. Yeah. Makes sense.
So from the requirement perspective, we are saying there are 20,000 users at the max. So like there will be 20,000 applications interacting with each other.
Mm-hmm.
So so in terms of the the expectations out of the system in terms of scalability or so what are our main expectations like in terms of availability, consistency?
So what is like now you have this system, this is the requirement. Like, what is your opinion that what are the like how important do you think availability is? How important do you think consistency is? And how important do you think scalability is?
Yeah, so okay, so consistency, scalability, and so I think among all these three, I think consistency is more important because as a end user, let's say I'm downloading a huge file and uh, let's say I download 99% of the data and at that time, if due to various reasons, if that file is not available due to network fault or hardware fault, if I lose that thing, then it's not a great user experience. But actually, I'm not sure like what should I choose.
Mhm.
S-
Okay, it's fine. Okay, let's say like we are okay. Like if the file is 99% downloaded, and if we don't have anyone available to serve, then we are fine. Then you cannot proceed. If we have someone, then we will try to redirect you to someone.
Okay. Okay. And okay. So I think availability point of view, uh, so there's nothing much actually. Let's see, like while I'm designing, as I get more understanding of the system, I can ask more questions.
Yeah, yeah, no problem.
Uh, okay. So now we have a client and server. So these are interacting with the rest of the systems.
Mhm.
So let me explore the right path, uh, uploading the files. So So I am the end user, and now I want to upload files so that rest of the people in my university can download these files.
Mm-hmm.
So let us say, so so this is my local system, and I'm trying to put the data in my. I mean, I want to share this file with the rest of the people in rest of the users. So once I upload this file, so I should be able to. So okay, let me write this. Right path. So once I upload the file, so first I should have. I think I should have a component which should which keeps the metadata about the kind of files I have, users. So I need one service or one component which keeps the metadata of the various things we have in our system, like storing usernames, I mean list of people available, list of files available, etc. So this component will be required to store this data. So
Yeah, right.
so in terms of like if we look at the what like we store the metadata, and if we look at when we need a database to store this data, and we can choose, I mean, by looking at the requirements, it looks like a very normal it's not very high scale data, like we have 20,000 users and 1 million files, which can easily uh, we can choose any database to store this kind of data. So I can go with the relational database, and I can keep two tables, one for the users and one for the files.
Okay. So one thing I want to mention is that this system should be like highly fault tolerant in the sense that any of the client and server can join the system at any time and they can leave this system at any time, right? Like you
Right.
can disconnect at any time. You don't have any like compulsion or something, and you can join whenever you want. So that that is something that we have to be careful about. Yeah. Okay.
Okay. Okay. So that means so I need to maintain. I mean, the people who are hosts which are available,
Mhm.
like people who are online kind of thing, so that I can route my requests to the people who are available. So I should maintain something like heartbeat service, which knows who are available currently, so that if I get a request to get a particular file, I can ask that service for this file, what are the which host have this file, and which are among them which are online currently.
Mhm.
So
Okay. Mm. So
so
now
metadata, yeah.
So my question is, so now you have this metadata, which is storing usernames, right? Which is the list of
Right.
available. So this has just the list of people available, and then you have list of files. And how would you know that which file is available where?
Yeah, so I should have one more table having mapping between who uploaded which file.
Okay. And where are we going to store this information?
So so I'm thinking so in terms of we can choose either relational database to store this data or a
Okay.
NoSQL database.
Hmm.
So if we look at the cardinality, so usernames, it will be 20K rows.
Okay. Mhm.
Sorry. And list of files, it will be 1 million rows. And list of files with users. So this is 20K into 1 million. So this will be 10 million, 20 million rows. So, so if it is a relational database, so I can have my data something like this, user ID followed by username, mm, status to see whether he's available, what is his availability, and maybe last seen. Not sure if this will be useful, but I'm just keeping this.
So, Nandini, like before we move forward, like I just want to ask one more question again. That so it okay, I agree that this will be stored in some relational database, but that database itself, right? So that database content, where are you going to store that? On what machine are you going to store this information? This metadata service, which
Right.
machine will host that database?
So yeah, so that's the actual problem, I think. So, yes. Okay. So, yeah, this should be available in each and every server component of application in each of the user's machine.
Okay, so this entire database we are going to store in all the users' machine. Do you think that?
Yeah. So, because this is there's no centralized server, right?
Mhm.
So, so this information will be propagated to as the system evolves. I think this metadata should be shared across those machines so that we don't dependent on any single machine. Or I think there is another option where we can keep this particular information in one. We can choose one particular server to deploy this kind of data.
Okay,
Only the metadata part, not the actual data.
okay. So you are saying that you have two options. One is we can have a small piece of central system where which
Yes.
only store this metadata, or we can like go actually completely peer to peer where we have
Yes.
no central system at all, and each So let's go with the complete peer-to-peer where we don't have any central system and we want to now store it. But now the problem with this design I see is that if, let's say, I start to scale my system, right? And if my users and files keep on increasing, then this metadata that each machine has to store
Right.
will also increase a lot, right?
Yes, it grows exponentially. Yeah.
So is there something we can do better over here so that like at least like we don't have this information on like entire information on all the machines?
So what we can, one thing that we can do is uh, among the existing user machines, we can choose some machines as you know priority servers or something, and only those will have the entire data, something like that.
Okay, so okay, so let's say we decide that some of the machines will be the one which are kind of, so let's give them some kind of a name like super nodes or
Yes.
super hosts, right? So they are the
Yes.
ones which will be storing. Okay, so okay, that's fine. So let's do that. uh, so
So
but again, like these super hosts also, these are the hosts which are storing, but again we don't want to store like in every super host we don't want to store all the information. So how would we do?
yes.
Are you understanding, like,
Means
because
yeah.
again the load will be on each super host?
Yes. So if I like we want to reduce the load, so normally if you want to reduce the load, we kind of use partitioning strategy so that when we get a particular kind of information, I can route it to a subset of the nodes, right? So, but I'm just thinking, since this is a very high possibility of machines going down, so if I want to go with partition to reduce the load on superhosts, I should again replicate the data, right? If something goes down, then I should be able to still serve the user requests.
Yeah. Hmm. Okay. Okay, so let's say, like, yeah, we are partitioning and also replicating so that like even if like some of the partitions are down, there is replication of that data through
Yes.
which we can contact and get the data. Okay, so now we have this. So now how will we actually so if a user wants to view like all the files available in the system, how does, like, what happens? So initially if I join the system, what happens? Like first I download this system, what will happen initially?
So downloading, you asking about the read path once I want to download a file, how the system should behave, or when we download the application, how it behaves.
Yeah, so when I download the application, how it behaves, like what will happen, what is the first step that will happen?
Okay, so once we have the application installed, so user, let's say we want to start with the upload the right path. User want to share his data to the system, rest of the users. So we can ask him whether he want to be superhost or not. So
Mhm.
let's say he want to be part of let's say he's a superhost. So and he want to share some data. So initially, we the metadata service will try to. So yeah, so I just so how does it communicate to other how does it communicate to its peers? So we
Mhm.
need some discovery service which will tell the application that there are other servers which are available in the system and can help in reading and writing. So how does that bootstrapping works? Because so let's say I'm thinking maybe without knowing the superhost's IP address, maybe I should keep some static IP addresses when I'm starting installing the application. Otherwise, how does it interact with other machines? That we need at least one server which I can talk
Okay.
to
Okay.
bring the existing metadata to my
Mhm.
local storage.
Okay. Okay. Yeah, makes sense.
So assuming that there is always assuming I know one at least one server IP address to communicate. So so when I start, I will register. I mean, I'll talk to that server and I'll register. I mean, assuming we need one service discovery, right? So to understand who are available, which hosts are available.
Mhm.
So I'll just
Yeah. Okay. Mm.
write it here. So some service discovery mechanism. So I'll register myself that I want to be a super host and this is my username and some metadata about me so that the list of superhost list will be updated first.
Okay.
Once that is done, I will get the existing information from the system, like the entire metadata. I'll pull it to my local storage.
Okay.
So now I know how many files are available in this system and uh, these three tables basically:
Okay. And now,
user information and the file metadata.
okay. So now, okay. Now I have list of files, and now if I want to download a file, then so let's say I have a list of file and I have chosen to download this file. So what will happen then?
Yeah. So now this is the read path. So so since this is a peer-to-peer system, so there is a mostly these are like commodity machines, right, which has the limitations and number of amount of data it can store.
Mm-hmm.
So what we can do is actually whenever user uploads a file, we should break it down into chunks and update the metadata service. I mean, we should do the replication and the partition, not partition, but we have to replicate. So once I want to upload a file, I break it down into chunks and replicate among existing machines so that the load when the user want to download a file, the load will be distributed across the systems.
Okay. So okay. So we are saying that if you are uploading a file, then it will be distributed, and Okay, uploaded among these peers. Okay, right. Okay.
Yes.
Mm-hmm.
So so in this way, let's say we have superhost, maybe, or so anybody who has more data without you know replication and dividing it into chunks, people who are sharing more data, they will be loaded more. So to reduce and to evenly distribute the load, we can share this metadata, and wherever, like, once we have divided into chunks, the metadata service can update all the machines to know for each file where all the chunks are available, so that whenever we get a user request, we can, based on the, so we can choose various ways to route the request, like uh,
Do you see any So, like, one option is that the host itself is having the file. One is dividing into chunks and spreading across. So the
yes.
advantage of that is we have divided the load. Is there any disadvantage of dividing in chunks uh, and spreading it across?
So yeah, as you said, the problem when particular user want to read, now he has to communicate, so he has to establish many connections,
Mm-hmm.
or yeah, so that's one problem. Yeah,
Yeah.
so
So
he has
the
to
problem,
establish multiple connections. True. Yeah.
because like nodes can go and come down, so then each file is dependent on many more nodes, right? It has
Yes.
to download that file. So
Yeah.
that is one thing. Okay. Uh, okay. So hmm, so now, so to read the file, like, first, can you repeat? So, like, let's write down the steps one by one. What were the steps?
Sure. So user want to download file, so he'll he'll so he'll establish connection with superhost, assuming superhost is acting like a coordinator service, which knows, which in turn talks. So let's say superhost talks to metadata service to identify which hosts have this file and available hosts. I mean, I just say, I can say identify available hosts. So let's say our file is available with, uh, so let's say my file is divided into 10 chunks and it is available across 10 hosts. So now the option one is talking to 10, uh, creating, I mean, so first of all, when I'm dividing the chunks, I should know the order in which I should be able to combine this data. Assuming all that is there, I will, I'll parallelly establish connection with all the machines, and then I'll try to download the data. But like, I'll just write this down. Get hosts establish.
Now, so basically, these superhosts have this information that this file is hosted by these machines, right?
Yes.
Okay, and I have the list. So now let's say, and we are saying, so will this list be fixed, or we can like, can more, will you design system in such a way that if more people are downloading the file, so we will keep on adding that, hey, now we have more nodes available to who can share this file.
Yeah. So yeah, I think it's better to update the list dynamically. So once I download the chunk, I should give an acknowledgement to the superhost. Then it should update the list where all this information is available.
Available, okay. And then now, so now, like, if I'm reaching a host, right, and that super host, and it gives me a list of servers where that file is available, and so what will happen now if those servers are down, those servers are not available?
Yeah. So I should. I think the metadata one which I receive, the mapping between the file ID, file chunk ID, and the list of hosts available. I can try with the first host, and if that's not available, after few attempts, I'll go in the next host in the list.
Okay.
But the only problem with this approach is there is a possibility of this information becoming stale. So
Mhm.
once, let's say I got this list where the file ID is available, and during that time, if the host remove that data, then again, uh, it I think yeah, I think that should be fine. So if that's not available, then I should go on to the next node to get the data back.
And then what about the superhost metadata? Like, when are we going? So the, if an superhost has a list of nodes that have files available, and if any of those node goes down, will, like, how will you design the system to keep that information up to date? Basically, that's the main question, right? Your superhost has
Right.
a list of files and a host, and it has to keep that up to date. So how are we keeping it up to date?
Okay. So let's say I have like so this is my file and it's divided into multiple chunks. Let's say FC1, C2, C3, and let's say FC1 is available in host 1, host 2, FC2 is available in host 2, host 3, and FC3 is available in host 1, host 3. So now
Now let's say the,
let's say I'm the host 4, which is trying to download this file 1. So
Mhm.
I know that FC1 is available in these hosts. So the question is, when H1 becomes unavailable, how do we update the actual mapping, right?
Mhm.
So so okay. So there are two kinds of failures that we can foresee here. One is when I'm trying to download a file, I know H1 has the file. I try to connect with H1 and get the file. One option is H1 is not available at that time, and
Mm-hmm.
another possibility is H1 doesn't have that file. So when I create a connection with H1 and will ask to get the file, if it says that it doesn't have the file, then I'll update my local mapping,
Okay.
and eventually metadata. I mean, I'll publish my information, and once there is a consensus, uh, once there is a majority decision, then the overall, I mean, whichever wherever there is a quorum, that will be the final update.
Why do you need a column here? Like, so H1 file, so a client tried to download H1 file and it was not available. So what are we using column for?
I mean, let's say, I mean, so the reason why I'm saying quorum here is I'm going offline, online very frequently. So I mean, I might have stale data, or I might have more up to date compared to the rest of the system, right?
Mm-hmm.
So quorum, yeah, I think quorum doesn't help because only the host knows more information about it.
Mm-hmm.
So yeah, quorum doesn't help in getting this.
Okay, I think we are like, I think we are mostly actually done with
Okay,
the things, and also we are almost with the time. So, do you want to wrap up and any last comments that you want to make or anything you want to add?
sure. So I just want to summarize my overall thought process.
Mm-hmm.
So the system has we have two components in our application, and uh, the server deals with the upload file upload part, where once I upload a file, it talks to super host, and which in turn talks to the metadata service, which will keep all the existing users and their attached files.
Mm-hmm.
And once I upload a file, it divides into chunks and keeps in various hosts replicated. So when I ask for a file, the metadata service knows in which host it's available uh, based on our replication factor. And I have a service discovery mechanism keeps uh, which keeps the latest available hosts list. And then when I'm requesting for a file, I'll initially talk to superhost to get the whichever file that I'm requesting, to get where all the what all the chunks available, and what is the mapping for each chunk where all hosts are available. And the client will try to establish connection with all the hosts, and then will try to download the chunks parallelly. Wherever it sees any failure, it will try to go to the next host to get the data back. And the problem here is, how do we update this mapping dynamically with so many changes in the system? So one approach we can think is, whenever the client is facing any problem, at that time we can update the list, or the host itself also can publish its update, so that rest of the system can capture that change. Yeah.
Mm-hmm. Okay. Okay. Great. Okay. Thank you so much, Menini.
Yeah, thank you, Abhishek.
Great. So, uh, yeah, it was a great interview and great discussion. Asim,
Yeah,
do, yeah. So do you?
good job, guys.
I see people have a lot of questions in the chat. Yeah. So at least I can. Yeah. I'm seeing this one part in the chat that why do we have a super host? Why do we have a super host? So does anyone want to discuss a design without a super host, the other possible approach, which is without these super host nodes? I'm just discussing
So,
various design first, and then we will come to feedback.
So Abhishek,
so,
what is a superhost? Like, how is it different than a normal host? I think I missed that.
Okay, so one of the okay, so the point behind superhost is, and also we can build a system without superhost, but the point is, so when I join a network, right, I need to know uh, what is the list of files available, right?
Mm-hmm.
And so how would I know who should I go to get those files? If I join the network, now I've joined the network, how do I know that where are all the files? How would I know that?
so Abhishek, would this be helpful if you can give some kind of because this question is kind of new to me, and in the past, I haven't given any much thought on this.
Mhm.
And if you have some idea, can you just draw out and tell your idea? Might be it is helpful rather than talking.
Okay, sure. So let me, Menini, is it okay if I quickly share my screen?
Sure, 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 Abhishek. Yeah, definitely.
So Abhishek, in the chat when we were talking about that, what it could be. So it looks like it's a DHT problem. Is that correct?
What is DHT problem? I don't know what is
Uh,
Distributed hash table.
it. Yeah, we can say it's a distributed hash table distributed among multiple nodes.
Mhm.
But yeah, but the major problem in this peer-to-peer network is, okay, you have a distributed hash table, but how do you know which nodes have that distributed hash table? Like in your network, you have so many nodes. How do you know? So let me draw it, and then probably I
yeah,
can.
I think better it's draw and give a little bit of systematic thing like how you're thinking.
Yeah.
Uh,
So basically, let's say we have a bunch of nodes in the system, right? Which are already there in the system.
so these are the hosts, right? Who can serve the files.
So these are my users, and they can be either host. They have
Or
dual role. They can either be host or they can either be clients. They can either upload or download.
okay,
So
but I can be a client and I don't want to serve
yeah,
as a
yeah, you can. Yeah, so it's either or both. You can be either client only, server only, or both. Yeah, you can play any
okay.
role in them, right?
So, but right now, what you're drawing is who are both, or either at least host.
Who are just available in the system, and they are just already available in the system, right?
And willing to be host.
They could be, so some of them could be host, so like this could be host as well as client, this could be just host, this could be just client, again this could be host client, so a mixture of these nodes, right?
Okay. So we have a lot of nodes, and now we have data to upload.
Now before we just upload the data, so like very first thing, when a node comes online, this nodes now downloads my uh,
And,
application.
and once one just want to interrupt. Sorry. So this could be my personal laptop, right?
Yeah,
I want
this is a personal app.
I want to be on the network, and there's no reliability of my personal laptop. My
Yeah,
battery can go down. I I just shut down my laptop. So this
yeah,
is a scenario where community kind of network we are building. Anybody can come and go out and at any point of time.
anytime, exactly. Yeah, yeah. So yeah, there is no reliability of any nodes. Yeah.
So this makes this different from any other data center. where we know the machines will be up all the time.
Yeah,
So
where we
this
have
makes
some reliability of the nodes that they can't go down just like any time, like at least.
yeah.
Like,
So this makes this problem unique and I think interesting.
yeah, exactly.
I
And
think, sorry,
that
one
is
thing.
one part. And sorry, just another part is, at least in data center, you know what are the nodes. And actually, like, yeah, it's related to the same problem, but here, because nodes can come and go anytime, so you don't know which nodes to talk to get your directory of files, or which nodes to talk to download the file. So if a new node joins the system, it does not know like who are the nodes which are available in this system, right? And so
Mm.
now that's why there are two approaches, because it's a LAN, like, so that's why, to simplify, if it's a LAN, then in my local area network, I will flood all the machines, and I will ask them if they have, like, if they are the client or server of this system, and I will flood them, right? And I will ask, like, either you are, so then I will know who are the machines, and from them I can collect the metadata and
And store locally.
right. Or the other approach is that, like, if I just reach a kind of a super host, right, then
Mhm.
like once I reach that super host, then through that super host is connected to other super host, and from them I can get all the information, so that I don't need to go to all the nodes. uh, and these super hosts actually have information about other systems. So basically, this is just reducing this initial design of flooding, where I have to go to all the nodes to get the information instead of going to all the nodes. Like, I have designed some nodes which will store all the metadata information, so that I don't have to. So once I discover one of them, then I don't have to go to all of them.
Okay, so let's stick to the superhost approach. Like we have superhost, and now the node comes online, so it can talk to all other nodes, right? Not all. It will get to know from superhost who could be in the nodes in the system, right?
So from superhost, it can it can get the list of files available. So basically, first it needs to know the list of files that are available. It does not need to know now uh, all the all the available hosts. So, like, these super hosts, they will talk to each other. Let's say we have these two super hosts. So, and my point was that one super host will not store all the metadata information, because, like, one thing is that the size of that metadata could also keep on increasing. So we want to partition that data, and also partition and replicate it. So these superhosts will talk to each other and finally create that whatever we were talking about,
But
distributed hash map, right?
superhosts are reliable machines.
Superhost are, like, they are more reliable than, but still they can also go down. Like, I can choose to be a superhost, but it's not like I don't have to be always available. Like, basically, these are the nodes which have chosen to be superhost, that they are trying to be more reliable, but again, they are not 100% reliable as well.
But at least at some point there should be one superhost in the system.
Yeah, at least we are assuming there is one superhost. If there is no
Okay.
super in the system,
So
then
let's assume that there would be a superhost, and if superhost could not uh, uh, have enough space or something, then it will share load between different superhosts. But my question is, let's say I'm turning on this system on day one. There's no list, nothing, no file is there. What will happen?
yeah. So initially on the day one, there is no file. So, like, so the list of files will be empty because no one is
Yeah.
sharing it.
Now I come to upload a file.
Mhm.
What will happen?
So you will, so either when the system first starts, it will create that first node as a superhost, right? And then this will upload a file. So in this file's metadata, we will have that this is the file and this is the host. And now, because we have only one node in the system, it is not replicated anywhere. So this is the only node hosting the file. If it goes down, we don't have access to that file.
Okay. And do so. Uh, so do you know in these kind of systems we do chunks, or that entire host should own the entire file?
I'm not sure, like, but
Mhm.
I think that entire hosting a file would
Okay.
be better, then like because then you have more dependencies. To download a file, you are dependent on many more servers to be available at the same time. Whereas
Okay.
if
But I
Let's
think
say one host have one file. Let's make it simplify.
yeah,
Like
So, but the requirement, as you mentioned, that this file size is any size, right? So if the host may not have the enough space.
then it won't take the request.
yeah, no, the
then
file
how
is
can
not getting.
he host it if he does not have enough space to like host the file? Why will it be a host then?
Yeah, the file is locally present on the host, so the file is already there, right? So there's no question about that. And I
Okay.
think the idea is that if you chunk it, if you think about like, now there can be hotspot situations. So let's say there's a movie or file, big file that's being shared, then everybody's trying to go to the same host, which is acting as a torrenter or a torrenter like the source. Then that will create a hotspot. So what if we can divide that file and spread across multiple hosts? Now, big depending on where the chunks lie and what kind of bandwidth that computer is coming from, we can choose to figure out like I'm going to get the chunk A from here, chunk B from there, and so on. And that way, it not only reduces the congestion that's geared towards a single host, but spreads across. And more or less, I can do the same thing in parallelly as well, right? Because now I'm no longer doing sequentially,
Mhm. Yeah,
right?
I see the advantage of doing it parallelly, but regarding hotspot, so even if we have replicas of whole files on these
Mhm.
multiple nodes, then also I can divide it, right?
If you have replica, like when you say
Of
you can
entire
divide it
file
as in,
without dividing into chunks, then also I can divide the load. That if multiple people are asking for the same file, I can divide the load. But yeah, the advantage of dividing in chunks is I cannot do it in the parallel, because then I only one machine has that. But doing it parallelly also, I'm still limited to the download bandwidth of the client. So can yeah, I don't know if
The other benefit I can think about, if we keep the single file, then let's say client partially download the file, so we can use the offset benefit to actually download it and utilize that whatever we downloaded so far.
oh
But
yeah.
in case of chunk, you have to actually re-download the whole. Let's say if you 90% download the chunk and connection lost, you will have to download it again.
Yeah,
Yeah, I think with the chunks, like you can treat the chunk as a file itself, right? That's not a problem. Let's say if your file is 10 gigabytes, you can cut in 10 different chunks of 1 gigabyte each. Then
Um,
within the same chunk, you can treat it as a
With
file. So if you lose a connection, you can restart it from 90%.
no,
yeah,
but then you need another
yeah,
system to maintain the chunks also. Which chunk is going where?
Right. That is the metadata information that needs to be available for the client to go back and get the chunks from all the
But
places to
but
reassemble it.
that can make system more complicated. Let's say my chunk is in 10 machines and one machine is not up. Now, can I get chunks from 9 machines and I can live without a single chunk from the 10th machine?
Yeah, I think the question is more to do with like how much scalability and throughput we want, right? So very clearly, I think we can talk more about it, but very clearly, if you have this notion of chunks, then you are distributing your processing, which means that multiple hosts the workload is spread across, and now you can get data from here and there based on best available paths and so on. But if you want to make a simple system, then you can simply make an argument that we don't need to go chunks. We can just have this one file be available through the single host, or take it further, I can say I have this one file being available at these 5 different hosts, so I can go and get it from one of these files and not go chunks. So I guess it just based on the interviewer and question, you can say what level
Yeah,
of complexity you want to handle. But definitely, yeah, there are levels to it, and chunking will definitely help alleviate, make it more scalable. But of course, will come with some cons, right, that you have to address.
yeah, yeah.
agree. But my question is, I still could not see end-to-end picture on my head. So that's why I'm trying to go really with the simple design, like how Abhishek started only for a university. So to make it really simple and then make it complex. But right now, Abhishek, another point for you. So now let's say one host is having the entire file. Now, uh, uh, now what other things we can consider? Like, should that entire file be replicated on other hosts? And based on the location of the client, we serve it from the nearest host. Is it all things matters in these kind of design? Do you know by any chance?
So if we are talking about LAN, right, local area LAN, then these things don't matter because everyone is within that local area. But if you're designing it for internet or something, then
Mm-hmm.
then your metadata, your super nodes will be storing the IP addresses of those machines which are near to you, and then when you are getting the metadata, you will connect to that super node which is near to you, and that super node will also have the list of nodes having file near to you. So that way you could do it, but in this
So,
case it's more simpler.
so let's say I'm a client, I'm just annotating. So I want to upload a file.
Hmm.
And first I have information from the superhost where all hosts are available.
Hmm.
Then I directly make a connection with the host and say, hey, I want to upload like 100 MB file, and host will say, oh, give it to me, and then I will update that file,
No,
upload that file to the
it's
host, and
not. I think it's not like this that you are uploading. So you your the f- if you are making a file in sharing mode, then you are saying that I am the host. So then the super host will keep this node which you have drawn C
Mhm.
as available, that this file belongs to C. So if someone else wants to download the file, they can contact this node C and download the file, and once they have downloaded the file, then they can also host it. So now in the table I have two nodes now who are like
Okay, in that way. So, but initially, how the host will get a file? It is something like I will get it from, I will download from internet or something.
yeah, and then I want to share that file in the network, right?
Because on my head, I'm still trying to visualize the torrents where people go and down this pirated movies or something. So it looks like they get from somewhere. They say, "Oh, I'm hosting." Another person who downloaded again says like, "Okay, I'm the host now," and then we are getting more and more hosts in the system.
Yeah, I think torrent system is little bit different, but here basically, let's say you are in a university, right? And on your local machine, let's say you have some something, some files, and now you want to share those files with people across the network. So that is,
Yep. I think just one quick comment. One of the easy way, if I'm thinking through all this conversation, one of the easy way to recognize or build the system would be to think like, what if there was a central service, right? So when Menini started with the concept, like assuming there's a central service, and if the central service, we know like who all the clients are, the central service, we know the fact like these clients have these files. So if you start with that notion and try to build from that route, then all you need to do is like take the central service and decentralize it. And
exactly.
what that really means is like decentralizing, meaning that the information that the central service holds now is going to be available with one or many nodes. And those are the nodes are nothing but what we call the super nodes, right? So you can say, now here are the three nodes, right, that are super nodes. And now what they will do is like each of those will replicate the information among themselves. So this is, remember the same thing, distributed hash map, right? Somebody said that. So essentially it's a map of information that needs to be spread across these multiple hosts, which we call supernode. And then now we need to deal with situations like what if the supernode dies, right? Or one of the supernode dies, then the idea would be that The super node will say, you know what, I see that we were supposed to be three, now I see two. So let me try to make some other node as super node. And what they will do is like they will replicate their metadata into the third one, right? So you keep on doing all of that thing. And since we I think we started by saying that this is more limited to a university. So definitely there's a LAN kind of going on. It's a very co-located or an internet network. And what that really means is that we can use UDP, right? We can use UDP to broadcast. So the superhost can keep on broadcasting the fact like, hey, I'm superhost, I'm superhost. So now the nodes or the clients, as they come in, they can get to know who superhost is, and they can talk to superhost to actually get the information about all the files that they know of, so that they can start the downloading or leaching process. And finally, I guess if we take this application beyond universities and we say, okay, this is more global, then I think we probably need some central service, like a very small central service. Again, the keyword is very lightweight service, and that lightweight service probably would need to know all the superhosts that exist within the ecosystem, because otherwise, we cannot broadcast. Basically, superhosts cannot keep on broadcasting to the whole world, right? So they need
Yeah.
to broadcast to or send a message to some common central service where all of the clients can connect. And once you get the information superhost, then it becomes decentral from there.
Why can't like if I'm the host, like I have a file that I need to send, then as I send my, like I can split the files into small chunks and then send those chunks to different hosts. And as I'm sending, I also know, okay, I've sent C1 to node 1, C2 to node 2, C3 to node 4. So like that, split into small chunks and give it to different nodes. Now new nodes who are joining the system, they can get, like, say, chunk 1 from n1, chunk 2 from n2, and they will know that by connecting any one of those hosts, right? Like they'll know by connecting to like one of those nodes, like I have only chunk 1 from my end, and then they can connect to other one of the nodes, and they'll say, okay, I have a chunk 1, but chunk 2 is also present in the other node. That is also possible, right? Or that's not?
No, I think if I try to answer, maybe Abhishek can answer better. I think the way I would think is like, if you have a limited number of nodes that you have to deal with, then what you're saying kind of works best, because now what can happen, every node can broadcast as what they have and who they are, right, and so on. But when we take the service into more broader spectrum, then you cannot broadcast. You cannot keep on broadcasting, because now the number of broadcasts that needs to happen across all the systems could be millions and billions. So you need some sort of concept where you want to centralize the information. And again, when we say centralized, we really don't mean like one central, but as opposed to this concept of these super nodes kind of, yeah, which could be hundreds, doesn't matter, or thousands, but not everybody's a super node, right? Not everybody has the whole set of information. And if you can rely on the super nodes to get the data, then that really helps to eliminate the chatter and the data that has to be replicated across all the nodes, right?
I,
Because
yeah, I see your point. Central service definitely will reduce the chatter. My point was not like if I have like 4 chunks, I'm not broadcasting to everyone that I have 4 chunks. Uh, Somebody has to ask me, hey, give me the chunks that I have, and can you tell me where you got these chunks from? And that
But
will
how would you know? Like, how would someone contact me? How would they know that they have to contact me for this file?
correct.
exactly.
That will be the
That's true.
first broadcast that I'm doing to one of the nodes in the server. Like a new server joining or new node joining, it would need to broadcast one time. That's one. Yeah, it would need to broadcast just once.
But yeah, that I think that's the whole point, right? It works when you have limited nodes, when you have a very well-defined ecosystem. But if you're gonna take it to millions and
I,
billions, then you cannot do that, right? It's so, because think about, now you're saying to the whole world, hey, who do you have this file? Tell me who has the file. Now a billion people is gonna say, I have this file. You're gonna be in trouble.
I see your point. Yeah,
Right. So the idea would be that, okay, there has to be some. I mean, again, when it's a supernodes, I would think we're not just saying one. I've even said it could be thousands, it could be tens of thousands. Just depends upon how big the network is. But the key thing is like, we want the system to be fault tolerant, and what that means, like, if the supernodes basically has to have a system where if somebody dies, then at least you want to have a minimum of these set so that you can start replicating to something else. So now you basically have this one guy who filled this part. Now what happens, I guess, if everybody dies and if all systems shuts down, then whoever comes up, like as Abhishek said, whoever comes up will become the supernode. Because I say, I don't see anybody in this world. I'm the only guy alive. So I'm going to broadcast and wait to hear an echo. If nobody's going to say that I am a supernode, then I'm going to be the supernode, and I'll kind of start to see the world. And then let's say for whatever reason now the supernode kind of comes up, right, from some other part of the world. So this guy can eventually become its own tribe. So there can be like partitions within the network, even within the university application. So there may possibly be a need for consensus in terms of merging these subnets, which are partitioned, because now you can think about it, for these 100 systems, I become supernode, and for some other systems, this guy becomes supernode. And now there could be possibility when this partition kind of goes away, then both these guys can see each other. You can say, okay, I was king here, you were the king here, so let's form one tribe so that we both are supernodes now, and I can share what I have, and what you have can be merged, right? So there can be those possibilities as well.
Yeah.
Okay, I think first we can give our feedback to Min and I, and then we can keep on chatting around this because we are already 10:30. Does it sound good, or want to chat first and then give feedback to him?
No, I think, yeah, you're right. Let's give him a feedback. And first of all, I just want to say whoever was explaining, like it was like really awesome explanation of the entire system. Okay, so yeah, so let me start with the feedback. So I think, yeah, Menini did good. So he, like, initially in the requirements, he clarified all the requirements, and then like I think when he was and when he was discussing about non-functional requirements, there I thought like some of the the one problem I saw is that I saw the format of asking question was very standard format, like which is something that you have practiced enough times and you are just repeating that thing, and it did not quickly adapted to the problem. Like the questions which you were asking were like very standard questions, that what is read throughput, write throughput, and like availability, which some of the things might not make sense in this kind of a question. So
Yeah.
that was one thing, but otherwise, yeah, but otherwise overall I think it then how you proceeded to the problems, and like how you answered the questions, like it was a perfect start. That first, like simplifying, having a central system which is storing all this metadata information, and then now we are saying, okay, now we don't want a central system, so now how are we dividing? You also came up with the thoughts of like in fact in fact like in fact making the files into chunks and dividing the load. So that was also like, even I was not thinking in that direction. I was thinking of keeping one file, but and as we have discussed now, that in fact like there are a lot of advantages of dividing the file into chunks. So that was also something great which you came up with. Yeah, so I think that's my feedback.
Thanks, Abhishek. So actually, this is my first mock, so I'm a little nervous. So in general, I want to understand when we want to gather the non-functional requirements. So I don't know. I understood now that this is not the best way. Like, so what is the no, like smoother way to get the non-functional requirements? Is it like instead of directly asking, do you want availability? Do you want consistency? Is there in what are the alternatives that we can ask?
Okay, so let me answer according to my understanding, and then other experts in Asim can elaborate more. Uh, so functional requirements are something which is expected that your system should and must do, right? And
Yes.
there could be like, it's not a standard that availability and consistency are non-functional requirement. Like like it could be a functional requirement that I want my system that it should be highly consistent, that I do not want to store any record which has a stale information or something like that, right? And that could in
Yes.
fact be a functional requirement of my system. So those kind of things are could be functional requirements in the system, but non-functional requirements are like that which like system that it's good to have, like you should build a system, but like those are like generic for all kind of systems, and that might not specifically apply to this problem. So the thing like scalability, right? Whenever you are
Right.
building distributed systems, you want your system to be scalable, and that applies to almost all distributed problems you are solving, most of them, right? So it's kind
Yes.
of non-functional that it is important that you have to build a system which is scalable, but it applies to all the problem. Simply, then the second thing is reliability, that you want your system to be reliable. Then security, you want the system to be secure. So all these things are non-functional requirement which are important, but probably like not too much like specific to that question.
So
Okay.
this is Naga. I just joined late. Sorry, guys. So just a correction, Abhishek. So I think availability and consistency also falls in non-functional. So I mean, like some people might not explicitly ask it in interview. Some people might say, interviewers might say like availability is important for me, but not consistency. So it's not. I think we can't take that in functional, but like it's part of non-functional requirements.
I think what Abhishek was trying to say, it's a non-functional, but there could be a possibility where the interviewer itself said as part of
Oh
requirements that
yeah, 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 correct.
like
Yeah,
it's
that's
now
what I was trying to say.
that's a top tier functional requirement now that it, the system itself is demanding availability as a requirement.
Yeah, 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 right.
I think the other thing I would say, like from an interview perspective, the interview needs to decide what those requirements are, not necessarily ask it. And you can say that, okay, based on your understanding, this is what I think would be needed, and then work with the interviewer to agree or disagree and take it further. In this example, if you think about like the availability, right? If you're saying the system has to be available 24/7, there is no such concept because this is kind of a peer-to-peer system, right? If everybody kind of goes down, there's nothing you can do. The system is not going to work anything, right? So there's no concept of availability unless until you're trying to build a central service which will cause it to go down. And then you have to figure out how you can scale or make the central service available 24/7. And if we talk about consistency, there's the only consistency I think we need from this service is the fact like when you do file transfers between peer to peers, you have to make sure that the transfer is complete to its nth degree, right? As opposed to some chunks getting lost and now you don't have the real file or the file that's kind of mangled, right? So that's become consistency for this one. And then the lastly, if you talk about scalability, we did talk about the fact like you can have multiple chunks of file that can be downloaded, so it can be scalable from that perspective. We did talk about that the super nodes can be replicated among themselves, and folks can become super nodes and so on. So now that's how you scale. And then from a latency perspective, if you think about latency, the latency is not tied to what we do because again, there's no central service here. Latency is more tied to do with the bandwidth that exists across these nodes, right? So essentially, this this example of system design, where all these, yeah, definitely it was very tricky in the sense I would think to figure out availability, consistency, and latency and scalability aspects because this is not a traditional centralized system. This is more peer-to-peer.
Yeah.
So, any other feedback for Min and I?
Yeah, I think
So,
one more thing, just quickly. Yeah, just feedback. But I think the only thing I say, like, in just my limited understanding, is the fact like if Menelai could have just gone a little more into block diagram. So, I would like to see him, make more progress in the block diagram. He definitely made good progress in terms of asking questions. Of course, there was some times where we were asking more low-level questions as opposed to working a little bit high level. But the idea was that I would think the idea would have been much little better if those inferences from what he was capturing could have been reflected a little bit more on the block diagram. So if there could be a little more progress in terms of components of the block diagram, that would have been fantastic.
And like, so would you think that it's the responsibility of interviewer to drive the interview in that direction, or interview he should also do it by himself? What?
No, I think for this one, I mean, this one is, I mean, this interview was more like the interviewer's, interviewee kind of sounded new. He didn't knew the system to begin with. So definitely he would have taken some time to come up with. The interview, we were definitely helped a lot. He definitely knew and above and beyond, I think, probably what probably is expected in an actual interview. So I think the interviewee needs to drive more, but this was more like a mock interview or different kind of session. So you kind of pitched in quite a lot.
Okay, so your feedback is that interviewers should be not like saying that much, right? Not giving
Yeah,
it that.
yeah. I would say that's probably. I mean, so the thing, this is more like, if you like the candidate, right, for some reason, okay, if you like the candidate for some reason, and you want to see, given some help to the candidate to get candidate take further, right? So this is what you did. But if the interviewer is expecting a self-driven candidate, then this conversation was not that great.
Okay, got it.
I think.
Okay, thanks for the feedback. So actually I have an extension to this thing. So what I had in my mind is once I was clear in my mind how the end system is going to look like, I wanted to draw the architecture diagram, but it's not clear in my mind. So I thought, too much, changes in the diagram might not look good. So I just I kept on discussing, but I didn't kept it in the diagram. Yeah.
There is no right or wrong thing in system design. So that's what we always chat. And if I would be at your position, I might also end up doing this. And to add to Abhishek's question, that's my personal opinion. For me, system design interviews should be something where you and your teammate are trying to solve a problem. And if you are not getting clear what is happening, what you will do, ask your teammate, hey, can you try something different? Can you try whiteboard, or you can try something different? But if you are good with the flow, what Menina is doing, I think that should also be fine, because it's the nature of the problem. This problem could be tricky, complicated. Men and I never have seen that, but you have some idea. Then you have to also account that factor. I remember I've been to one system design interview and I was totally clueless about that. But still the interview was fine because I was trying to bring things on the table, like what Men and I was doing. And he was trying to probe more into in terms of that, like how you are doing. And if you are happy with that probe, I think that's fine. If you're able to capture data points, what you're trying to see, you're okay. I think that is more than sufficient. It could not be a standard rule like functional requirement, non-functional, very high-level system design, and then deep dive. And there could be some other kind of problems which people can ask you, where I remember somebody was telling me that a problem where they got like, you have a perfect system. What you will improve on that? Yeah. Again, abstract question.
No, I think it's just how the candidate takes and solves the problem, right? That's the main thing. And you said it very well. It just depends on the interviewer, and then the idea should be, of course, the idea should be that it's more like a team effort. And that's why the interviewer will definitely give you hints, clues, and tries to hold hand with you at certain times to take you forward. And if you can take the ball forward, that's probably more than enough you need for this. But just depends.
Yeah, great feedback, guys. So from me, this is Sai. So I have like a couple of points here. The candidate really started very well, asking questions about the functional requirements. That is really good. And then I see that candidate couldn't understand the whole system, the functioning of it in at least like a bigger picture. So that is the reason why he couldn't come up with a neat, at least peer-to-peer overview architecture diagram. And he does mentions about the partitioning, clearly distinguishes between the read and write path, as well as mentions the discovery process, diffs and chunks, all good points. I only wish that he would have gone a little bit further into it, because I see this problem is like a depth oriented rather than a breadth oriented. And yeah, the moment interview candidate couldn't decide on like availability and consistency, it's a big no. At least like we should lean on saying one thing, why not, and why I should take that. And also like things like DB, right? Like when if I say directly that I will choose the RDBMS, that may not be a right approach. We may not need to start with why RDBMS. And also like yeah, either it's perfectly okay to take the superhost or like a non-superhost, but we can like trade off the things with the interviewer, saying that okay, I have this much for this I will be going with this approach, and let's design in this way. And the last one point which I had was like the functional requirements, which are really good. And if I'm not wrong, it took around like 13 minutes or 12 minutes to get into the next level. So that, considering like 45-minute interview, it will be a little too much, but considering it a 1 hour interview, it should be perfectly fine. But overall, like yeah, it should be more driven from a candidate. It should have been more driven from a candidate. But apart from that, really great job, Minani, and yeah, really great job, Abhishek. I appreciate you guys doing this.
Yeah, thank you, Sai. So great feedback from all of you. And especially thanks, Abhishek. You really made me comfortable, because I was a little nervous this first time and never encountered this problem. So, and
Yeah,
you,
so
yeah,
one thing I
thanks.
want to say is like, so how much hints I was going to give, I initially could figure out how much you are aware with the problem. So when you started off saying that is like Google Dropbox, something like that. So from that point, I started to understand that you have very little idea about this problem. So from that moment, I started, like in my mind, I had that I have to give you bunch of hints if we want to proceed in this problem. Otherwise, we might get stuck.
Yeah,
And so
And
that was my whole thinking. But yeah, but sometimes, yeah, I see that other people have also commented this, that I was giving too much hints. So probably.
no, I think that was fine, Abhishek. Let's say if you are a seasoned interviewer and you take every week or every month and you're asking the same question, you yourself get a pattern where people will get stuck. And intentionally, unintentionally, you would be helping them. You know, like this person would stuck here for sure. And you don't want to waste his or your time to just uh, beating around the bush, but rather than want to get enough about that person. Because you know, like most of the candidates get stuck here. So why to waste time there?
Yeah,
It's
yeah,
not a probe anymore then.
yeah. Okay.
That's what I heard from some seasoned interviews. Like
I,
they tell, we immediately know that this person is going to be struggling here. So let's get that person out of there and then move forward. Okay.
That's not always possible, that I mean the candidate is aware about the problem domain. So in that case, that's the interviewer responsibility to actually help them to actually explain the business or the problem.
Yes. Interviewer could be from any domain.
Right.
The candidate could come from any domain, and generally, it now depends on the interviewer. Like I have seen, there could be three things interviewer could do, which I have seen in my personal opinion. That one, they pick a problem from the candidate domain. Like let's say I am working on a retail, the interviewer would put me a problem where it could be retail kind of system, which I'm familiar, or interviewer trying to see something which he is working on, to see if this person comes to my team, how this person thinks in a different way or can give something different. That could be one possibility. The interviewer bringing their own real-time problem, Or then third, it could be really general, like anything which is there on the net. Just pick anything, like a Twitter design or Facebook design.
Exactly. I mean, I can give the example for Facebook and Twitter. Before actually practicing these system design, as I don't use these Facebook and Twitter, so I'm not aware about what is exactly the timeline in their terms, user timeline or home timeline. So if at the first day somebody asks me that design the timeline, so I will say that what is that timeline? Because I don't know.
That is also fair call. Like if you don't know about that system, like let's say you don't know about peer-to-peer, it's okay to first ask, like, can you give me some examples? Like
Exactly. Yeah.
I have not seen ever in my life how I can design the system now.
Yes.
So I think this is a good example where uh, we don't know much about system, how to proceed, and that's why I'm saying like, okay, Min and I was fine, but I can't guarantee whether the interviewer would uh, accept or reject the candidate. So lot of more practice is needed. That is my suggestion. So I want to little bit hijack this discussion to, if we are done, I was having another point to bring upon.
Yeah, sure.
So, Abhishek, were you there in that discussion we did a while back? We are designing a build system.
Build system, build and deployment system.
Yes, build and deployment system, exactly. So, you remember, if you were there, you remember we were talking about how the deployment will work.
Yeah,
So-
I recall that. I mean, somebody pointed that P2P when you deploy, so you just push the file to one system, and then from P2P network, the other server will pull it from there.
So let's say these are my all the build, all the servers, and now a new build is available. So could this architecture or design could be used there? Like I put it on one system, and it could share with other, and then it start broadcasting.
So when you mean by build, is it like
जरूरी थोड़ा ना Amazon पर कास्ट दिता हुआ ऑप्शन और क्योंकि ਤੁਸੀਂ ਦੋਨੋं सेम नेटवर्क ਤੇ होने चाहिए ये थोड़ा बॉस ਨਾਲ कनेक्ट है फिर आना चाहिए
I will mute this person.
so Asim, when you mean by like a build system, is it similar to a Jenkins?
It could be anything. We had another system design question a few days back. I'm not going into a lot of details, but the idea was once your build is ready, like let's say somewhere in S3, and all these are my machines, I just need to distribute to all the machines. So there we just touched on very high level peer-to-peer system, but we never went into so much depth, like how exactly the build, the servers would distribute. So let's say you have like 10K machines in your farm, and now a new build is available. So it's very difficult to go to each machine, but if they talk peer-to-peer, then they can do it really fast. I'm just throwing some idea. If you encounter a build system in your interview as a design question, then you can think in this direction.
Yeah, so like if the system is in my control, if I have everything, then even if I have to distribute these build among multiple nodes, it's always simpler to design a system where like you kind of have like one of the leaders who will be distributing the load, and then that leader has replicas, or like if there is a failover or something, then you elect a new leader. But it's easier to redirect the things through leader than like directly doing peer-to-peer. So in this build kind of a system, like some of the nodes, they can be taking care of like who are the machines who have the jobs assigned to them for build, who are the machines which are free, and that kind of a system where someone is orchestrating. If we are building peer-to-peer, we can build, but I think it will be harder. Like, and the similar thing I have seen in the consensus protocols also, like there is this Raft protocol and there is this Paxos protocol. So Raft simplifies a lot of the decision making by first electing a leader, and then that leader takes the decision on your behalf. And it's not that it's not a fault tolerant. If the leader goes down, you will elect a new leader. But like having that one central piece, then a lot of things get simplified. So this is what my understanding is.
But Abhishek, my thought process here is that consider you have a build system somewhere in the another data center, and the latency here is, let's say, 200 millisecond, and your build is say 1 GB. So when you upload the data from here to here, so it takes some time to reach here, and you replicate 1 GB here, right? Now there is no point to actually use the same latency for all these nodes, right? These nodes are close by this, and there is a latency just like 10 millisecond now.
So the build system will first like talk to this central system and ask that where should I upload it. I think it won't be that it is uploading, if you are saying that it's first uploading to the leader and then leader is sending it to a follower. In this case, the leader's role could be just deciding that out of these nodes in the network, whom should you actually upload your build. And then once it has made that decision, then the S3 node can contact that node to actually upload its build where that build would be built.
You can say that, I mean, where I'm uploading as a leader node for this small network. Yeah, you can say that too.
So I would like to mention the point that I have, at least in my experience, not seen a system with a peer-to-peer more than like a tens of thousands of nodes, right? Because like for an university, it makes perfect sense to have a LAN BC++, but are there any real life examples where like peer-to-peer has been used more than like a million users or something? That is when we need like a super host, or definitely need a super host actually. So
yeah, but if that's the point, then the build system, I think, does not have that many like nodes, right?
okay, so I mean, yeah, so fine. If we are talking about peer-to-peer, then it should have like much lesser than a million nodes. But yes, fine. Then if the build system has less than 1 million, then okay, that argument makes sense.
Yeah.
So when the file system problem which we discussed earlier, when the system will come live, so we would be bootstrapping with some number of nodes like superhost, like couple of nodes would be always there, right?
Yes, like there could be few approaches. That one is like the when you're downloading, it has the list of some super nodes which it has last seen, or it is talking to, like it is broadcasting that message to all the nodes in the network, and once it finds a super host, then it stops sending the message. But I think that basically destroys the point of superhost, because the point of superhost is you don't have to broadcast the message. But the thing is, then you have to broadcast only during the bootstrap, and then whenever next time you want to get the information about the files, that what are the files available in the system, now you know who are the superhosts, so now you can just contact those superhosts and then get the list of files.
Okay.
But yeah, like there could be few approaches, not one. Like either initially while bootstrapping, either you are broadcasting to find the superhost, or that information of superhost is already like
Available to a couple of machines, maybe.
Yeah, available. Or actually, wait, one more thing we can do is that like each of the nodes in the system, we can store who is the super host. So now if I can contact just any machine in the system, I will know the IP address of superhost, and then I can just contact the superhost. So then I just need to contact one node, because every node can like save this small information, because every node knows who is the superhost, right? If they have been in the network for some time. So as soon
Then
as
while igniting the system, while turning on the system, so that metadata, that kind of information will be stored somewhere in a static file or somewhere like that, or dynamically we will do this everything. Like
so
initial IPs for the initial superhost systems.
yeah, there would be initial information, but the thing is that initial information could be incorrect. It could have been stale. So then the fallback, then we also need to write the fallbacks, that what if the information that we have is no longer correct. So then in that case, we also need to do what to do next. And then there are various approaches. Then either you broadcast to various nodes, or like, or there is some central place that you contact. There could be a few different approaches.
Thank you so much, Abhishek. Yeah.
Okay, guys. I think we are almost at 11. We can wrap it, and if you guys want to check, we can stay around, but I'm going to stop the recording.